What if we could look at our world from above and warn farmers about problems in their fields? Help firefighters battle wild blazes. Assist states in managing their lands. Even limit the threat of disease around the globe. So today we can, thanks to a NASA-led effort.
This is Apollo Saturn Launch Control. We passed the 6-minute mark in our countdown for Apollo 11, the flight to land of the first men on the moon.
It was a time of tremendous achievement.
Roger that.
Triumph of technology, and a tribute to the human spirit.
Looks like a great place.
The Apollo program taught us a lot, not only about the moon, but also about our own planet. For the first time, we saw Mother Earth in her entirety, a beautiful, unified whole. Today, spearheaded by NASA, researchers continue to use the unique vantage point of space to study our global environment. At the heart of these studies is remote sensing, scanning the Earth with a variety of instruments from high-angle points of view. Coupled with the wide-ranging work of research teams at ground level, this comprehensive approach to the study of our planet is expanding our understanding of how natural processes affect us and how we might be affecting them. It's called Earth System Science, but its benefits extend far beyond laboratory walls. Agriculture is a very important part of our national economy. No one is as subject to the whims of Mother Nature as the U.S. farmer. Early detection and eradication of problems like crop-killing diseases is often the key to success. That's why many farmers today are looking up, hundreds of miles up, for help. The same remote sensing technology used by Earth scientists can pinpoint crop problems, even those invisible to the naked eye. Called precision agriculture, the information allows farmers to take corrective action before it's too late. No one can attest to the value of information like this better than the $6 billion a year California wine industry. When the roots of grapevines in the area were being attacked by this tiny parasite called phylloxera, NASA offered help.
For the last 10 years, NASA has been trying to get remote sensing into more commercial uses, to develop more industry partnerships. We called up about 4 wineries last fall and met with about 4 different groups and explained to them what we wanted to try to do. And Mandavi was the one who said, "We're your guys. We want to do that same thing."
Vintners were frustrated by the fact that vines being damaged by the deadly bug looked no different than their healthy counterparts.
So there's where comes NASA, because the very sophisticated technology, remote sensing, allows the detection of stress before we can ever see it with the naked eye. And that gives us a glimpse into the future so that we can do a better job of planning for the eventuality of the loss of those vines.
The infected vines were destroyed. A key U.S. industry was saved.
Very good.
Every year, massive storms destroy lives and property along our nation's shorelines. When Hurricane Bonnie was bearing down on the East Coast, a team of researchers from NASA and NOAA aboard a DC-8 aircraft had an unusual goal: fly right through the heart of this powerful storm. Using a variety of instruments, including airborne lasers, the mission was to unlock the mystery of what makes a potentially devastating hurricane like Bonnie tick. As the onboard team gathered data, satellites passing overhead watched the storm as well. This particular spacecraft observed unexpected massive chimney clouds in the hurricane's interior. The goal is to learn more about the complex structures inside these potentially deadly storms and better predict their behavior. Knowing where a hurricane is heading will allow state and local authorities to streamline disaster mitigation efforts, sparing lives and reducing insurance costs. The damage caused every year by raging wildfires, particularly in the western United States, is equally devastating. Ironically, the best way to minimize this hazard is by intentionally setting fires in areas susceptible to these catastrophic events, a time-consuming, costly process. Using airborne sensors, NASA and university researchers developed fire potential maps like this. Vegetation most susceptible to wildfires is depicted in dark green. Information like this helps firefighters pinpoint where to do controlled burns, maximizing resources. Remote sensing technology also can provide invaluable assistance during an actual blaze. Carried aboard an aircraft above the fire, instruments locate hot spots where firefighting efforts should be concentrated. These life and cost-saving techniques are currently being made available to departments throughout fire-prone areas. Through a data purchase, NASA obtains satellite imagery of the entire Earth every 48 hours. Intended for scientific research, this imagery is proving invaluable in a variety of other applications, including floodplain management. The ability to survey these areas before and after a flood is critical in minimizing future loss of life and property. If you watch the nightly news, you're probably familiar with images like this of the El Niño phenomenon in the Pacific Ocean. Also produced from satellite data, these sea surface temperature maps allowed scientists to predict this warming of the waters before it actually happened. Knowing it was coming gave emergency personnel time to prepare for El Niño's damaging effects. Space-based Earth sciences instruments also track the movement of smoke from large fires around the globe. Sometimes the smoke comes from natural disasters like volcanoes. Other times it's human-induced, resulting from the clearing of land. Regardless of its origin, the smoke often contains harmful chemicals that can cause respiratory ailments and other human health problems. Together with traditional sources of pollution, this airborne smoke might also contribute to the depletion of the ozone layer that shields us from the damaging rays of the sun. The ability to monitor events like this in the Earth's atmosphere allows policymakers to make informed environmental management decisions that could dramatically impact the quality of life for generations to come. NASA also is stepping up efforts to understand links between human health and environmental factors like temperature, rainfall, wind, and vegetation.
And why it's so important is that with the variety of changes in climate that we're seeing, more increased climate variability, drought here, rain there, El Niño, La Niña, these weather phenomena are spawning or fostering diseases around the world.
For example, many nations are increasingly plagued by outbreaks of infectious diseases like malaria. Using remote sensing, NASA and university researchers can locate the breeding grounds of malaria-transmitting mosquitoes. They're also attacking the growing Lyme disease problem here in the United States by pinpointing areas prone to this crippling ailment.
What we're applying is geospatial tools to tell us where the disease is, where it's going, who might be infected, what are high-risk areas. Information that can then be provided to the public health professionals around the country and around the world.
A sound transportation infrastructure, including highways, railways, and waterways, is the economic backbone of our country. To remain effective, this infrastructure must be continuously updated. A number of factors, including the locations of existing homes and wetlands, must be considered in planning these improvements. In Mississippi, NASA remote sensing technology is giving transportation planners the comprehensive perspective they need to make the best possible decisions for their communities. Making informed management decisions is the goal of every U.S. state, and Maryland is no exception. Much of the Chesapeake Bay, a national treasure, lies within its borders.
Although Maryland's a relatively small state, we frequently use satellite imagery and remote sensing technology. The reasons are really pretty simple. They provide us with cost-effective and timely solutions for many of our management problems.
Combining aerial videography and satellite imagery, Department of Natural Resources staff map vegetation types throughout the state. Comprehensive land cover information like this enhances the effectiveness of various conservation programs. Like their colleagues in other states, Maryland staff also utilize a Geographic Information System, or GIS, an electronic atlas based on satellite imagery, maps, and aerial photographs. A variety of key management information, including historic sites and tax parcels, is incorporated into the system. This electronic atlas also is portable.
Looks like we have a total or partial fish blockage here.
When AmeriCorps workers head into the field to inventory streams, GIS travels with them on handheld computers linked to global positioning satellites. Maryland is currently working with a company called EarthSat to revise its detailed land cover and wetlands data.
The red indicates where the wetland has been lost. This technique allows us to very quickly assess where the majority of changes are occurring to the wetlands, and it's affordable and it's quick.
This animation shows the spread of development in the Baltimore-Washington corridor over the last 200 years.
It's a major issue to try to balance economic development and preservation of land and the environment. With the big picture in front of us, it's much easier for us to take these kinds of preservations and growth initiatives and balance them off with the environment and set up a long-range plan.
Most of the earth sciences data used in the various applications we've looked at in this program are available through a growing national network. For more information, go to the NASA Earth Sciences webpage at earth.nasa.gov. You can also write to this address. Earth Sciences. Distance-based research with close-to-home applications.